Hi, you're watching Saturday in the Woodworking Shop with Andrew Pitts, where we talk things woodworking. All my tools are connected to a dust collection system where I have 6-inch piping that goes through the floor down to a Cyclone separator that's in the basement. I got my guidance mostly on the web from a website by a guy named Bill Pentz. And his contact info on the website is billpentz.com. That's Pentz.com. He's got the most extensive website about the theory and practice and construction of dust collection systems for wood shops. So if you don't remember anything else from this Saturday in the Woodworking Shop, remember billpentz.com, because you'll learn a lot. I first had to figure out what kind of airflow I needed for the various tools. I already had a Delta blower, the kind that's supposed to sit on top of a 55-gallon drum. So I used that blower. It's got a 2-horsepower motor. It's a 12 3/8-inch diameter blower wheel, and it pulls about 1,100 cubic feet per minute of air maximum. And that blower was made so I could hook it onto the Cyclone separator that I made, also using plans from billpentz.com, and it worked very well. Now, to move dust in a dust collection system, you have to have a few things. First of all, you have to have enough volumetric flow, cubic feet per minute, to suck in all the air around your hood that you put at your tool. And so probably the most restrictive tool needs about 800 cubic feet per minute of airflow. So you've got to be able to develop that. You also have to have enough velocity of the air in the ducting so that the dust doesn't settle out. So typically you need to have, say, 4,000 feet per minute. 6-inch ducting will do that. I used steel ducting, spiral wound steel ducting in my system. Now it comes in 5-foot lengths from a place called Spiral Manufacturing. And you hook these sections together using these couplings that fit inside, and that gives you a very, very smooth airflow. They make elbows that are really large sweep elbows. They'll also make Ys. Those pieces all fit together, and then you seal them with something called a 601 compound. It's called iron grip. Again, when I designed my system, I had to figure out where all my tools were, what all the lengths of pipe were, and so I made a diagram on my computer-aided design. You can see that. That's basically looking at my basement with all the pipes coming up through the floor to the various machines. So it's not a trivial matter to build one of these systems. But I will say that it really works. I don't have tons of dust on the outlet of my planer. Matter of fact, I hardly get any dust in here at all. There's hardly ever any dust in the air, no matter how much I'm working, because the system works so well. The Cyclone separator, which I'll show you in a minute, feeds into a couple of really large filters, about 600 square feet of filter surface, and that air comes back into the shop so I don't lose my heat in the winter. And those filters come from a place called Wynn Environmental. They're up in Pennsylvania, and you can get those filters from them. Now here's my joiner, my 8-inch joiner, and you can see I have to make a custom pickup hood for each tool. You can see the blast gates. I simply open up the blast gate when I'm going to use a tool. So that one's for the bandsaw. Shut that, open up this other one for using the jointer. Now you can see this gray kind of paint. That's that iron grip, that 601 stuff I was telling you about. Once you assemble the parts of the pipe, and I used rivets to assemble mine, then you go ahead and you paint all the joints with this 601 compound, and it seals it up. And I mean, this is from 2004. No cracks, nothing. Back here on the radial arm saw, I made a shop-made hood. The radial arm saw kicks that dust right back into there, and it goes on down through another flexible hose and under the floor. On the compound sliding miter saw, what I did there was, since this thing can tilt around, I needed a movable hood. So I went down to the dollar store and got a big laundry basket and cut a hole in the bottom of it and attached it to some pipe, attached it to a flexible hose. See if you can get that here. Okay, pipe, flexible hose, blast gate, and down into the floor. Okay, now we're down in the basement, and you can see all the piping I have in the overhead all goes over to my Cyclone separator. Now all these joints, again, are these low angle joints using the spiral piping fittings, and they're all coated with that 601 compound, that iron grip. Everything comes on down through a flexible hose again, so I can move things a little bit with a spiral wire in it, to my blower and Cyclone assembly. Now there's the Delta blower. Now the Cyclone separator is designed to separate out, virtually all the dust into, in my case, I have it going into a big box, and using a snow shovel right over there, I can shovel this stuff out into the garbage can and take that out into my ever-growing pile of sawdust outside. The Cyclone is something I built with plans from Bill Pentz's website. He actually has a spreadsheet there where you can enter the dimensions of your space, and it will calculate the size that this has to be. Now, for a Cyclone separator to work properly, there's some important dimensions. There's the ratios between the height of the cone, the diameter of the piece, the total height, that have to be observed for this to really separate with high efficiency. The dust and air come down through the hose into that rectangular opening and then start swirling around the inside and down the ramp that you can see the rivets for on the outside. Swirls around and around and around, and as that air gets pushed down farther and farther into the cone, it has to swirl faster and faster and faster while all the heavy dust separates out to the sides of the cone and falls down into the bin. Somewhere 2/3 or so of the way down that cone, the air is just too much air. It has to reverse direction, and what it does, it reverses and goes right up the center of that swirling tornado inside there and up into the blower, and then the blower takes what is now almost entirely air with maybe a little bit of fine dust and blows it through the wall into the space where I have my filters, and you can see the door shut on that right now. That space is actually inside the air-conditioned and heated volume of my workshop, while this blower is in the basement that is dehumidified but not heated and air-conditioned. So that air and fine dust mixture comes on down through the wall and into these two big filters that I have. Each of these filters is about 300 square feet of filter material. The spec on this is something like 99.9% of half micron dust, because what you're worried about is the really, really small dust particles getting into your lungs. It's one thing to have a clean shop, but it's another thing to have clean lungs. And so you have to have really good filters with a lot of surface area so that air can flow smoothly. Now I carry a remote controller on my belt, and it fires up this thing. Here's the remote controller. You can see it, got a couple of buttons I put on my belt, and when I hit the on switch, I can run the machine there, turn it on and off just from that controller anywhere in the shop. So what I do is I get to a tool, I open up its blast gate, and then I hit the controller button on my belt, machine starts up, and I'm collecting dust.